Ladies and gentlemen, welcome. Today I'm going to show a update on this post motor over here. What I'm going to show today is basically the same what you have seen in the previous video about this setup. In the previous video I will put the link of that video in the comment section. I had on the output two transformers, and those transformers gave me the ability to put a max load on the system, and with that max load the output of that I can use it wherever I wanted to use it without putting any more load on the system. Basically this is the same. The only thing is I'm doing it now with one transformer, and this transformer is a 1:1 ratio. The other two I had over here were 1:12 ratio. The system is running on 22 volts, same as in the previous video, and around, let's say almost 750 milliamps. And in the previous video it was around 825. That's basically the same input. Now the output is going over here to the light bulbs, but at this moment I am just bypassing them, and I have 75 volt DC output on the transformer. The way the transformer is hooked up is very easy. One side of the output comes over here, go to the beginning of one side of the transformer, and the other end is coupled or connected to the other end of the second winding of the same transformer, of course, and then goes out the other start. So basically I'm using the two start of the transformer. The two ends are connected together, and the output, one wire is connected at the two ends, and one wire, the gray ones, is connected to the start. Sounds difficult, but it's not. Anyhow, it goes to the bridge rectifier, and that's what gives me 75 volt output. The input is now almost 750 milliamps. Then I'm going to put the lights in the system. For 230 volts 1 watt LED lights in parallel. The output has dropped now roughly 10 volts, which is more than normal because a little bit of that energy is now going to the lights. And the input, just before it was almost 750, but right now it's, let's say it's 750, just a little bit more, not much. Now the output, I'm gonna short the output like this. 0 volt output, as you can see, and it is already going to the 700 mark, and the system is speeding up. But as in the previous video, this is not a gain. What it does is let you put a maximum load on the system, and then you can use whatever output you have out of that maximum load any way you want. But when you use that that output, it makes the system speed up a little bit. So now it is running at let's say 675 milliamps at 21.9 volt inputs. Gonna disconnect it again. Wrong one. This one should be here. There's the voltage output, and now the milliamps is climbing back up to 750. That 750 mark is its maximum load. Whatever I do with the output, It doesn't go higher than 750 milliamps. Gonna show you the lights in the dark. They are pretty good. I can clearly see the other side of my workbench. Yeah, nice. This battery over here has been charged before, so it should be almost it should be full, around 13 volts. Battery is 13.12. it is nice and full. Gonna charge it a little bit. When the battery is full, it's always harder to charge than when it's empty. Let's see if I can charge a little bit. Yeah, it is climbing a little bit. So yeah, it can charge. So there is some potential after that behind those 74 volts. And of course the system is speeding up a little bit. And the input is now 700 milliamps. 50 milliamps less than before. Same input voltage. Still have some lights. They are a bit dimmer than before. As you can see, the battery voltage is climbing. The best thing for me to do is to put another transformer on the output to make that 74 or 75 volts something around 35 or let's say 20 volts. So ratio 1:2 or 1:3 would be optimal. Lower the voltage and increase the milliamps. But as you can see, it is charging, so that's a good thing. Now I'm gonna show you another thing that I've seen with this system. The battery is out of the way. Oops. I'm measuring now the output. Output is now 64 volts. I have it now on the 1000 scale, 1000 volt scale. The reason for that is what I'm going to do now. I'm going to boost the AC over here at this point. When I do that, you will see that the voltage goes way above 1000 volts. So maybe I can do something with that. And when I boost it over here, it doesn't affect the input over here. The input is now 750. It stays the same because of this transformer that puts the maximum load on the system. Now I'm going to boost it. I have to be careful because there is some power behind those sparks. Gonna pause it and let you see the voltmeter. Hopefully I don't damage my voltmeter in the process. Here it goes. You can hear me pulsing it, and as you can clearly see, the voltages are way over 1000 volts. So maybe, oops, no, it didn't die, still okay. I am doing now without the lights, but I can also do it with the lights, as you can see over here. Doesn't matter. Yeah, it makes you nuts, I know. What I'm trying to say is machine maybe, and not machine is Dutch, sorry. Maybe at this point I have to make like a pulsing, like a spark gap, something over here. So I can have the lights and more output. Not more output, a higher potential voltage. The question is that better or not? More. That one I do not know at that moment. Gonna do it one more time without the lights. this is what I'm doing. You can see the sparks. Yeah, you can see them. And you see the voltage going absolutely bananas. So yeah. Anyway, I will see if I can, yeah, have to make something over here at this spot over here. We will see. Anyway, that's it for now. Just a little update one more time about this transformer. One side goes to the start of one winding. The two ends of both windings are together. That part goes to one side of the bridge rectifier, and the other end, the other start of the transformer, which goes to one side of the output, also goes to the other side of the rectifier. 1:1 transformer ratio. This gives you a certain maximum load on the system, and you can do anything with the DC load and even do anything in between over here at the EC part, as you've seen. Hope you enjoyed it. Thanks for watching.